What is cold plasma? Let's understand. Like solid, liquid, and gas, plasma is also a state of matter, which is also called the fourth state of matter. It was discovered by Sir William Crookes in the year 1879. However, the terminology was given by Irving Langmuir in the year 1928. Heating of solid converts it to liquid. Heating of liquid converts it to gas. Heating of gas at a very high temperature converts it to plasma, hot plasma. Hot or cold, plasma has some interesting properties. Unlike air, which is a mixture of gases and is non ionized, plasma is composed of 80% of helium or argon and 20% of nitrogen and oxygen. Along with that, although plasma is neutral, it is ionized and can conduct electricity. However, heating is not the only way to produce plasma. Plasma can also be produced by electricity, leading to ionization of the inert gas, producing cold plasma. All the properties of the cold plasma are similar to that of the hot plasma, except the fact that cold plasma is cold. Therefore, it's comfortable on skin and is suitable for the use in medical devices. The electrons in a cold plasma can reach up to 5000 to 10,000 degrees, but still the temperature during skin contact is less than 42 degrees. This is because only a small number of ionization events happen, producing limited number of high temperature electrons. This is why the resultant heat that reaches the skin when touched is very low. Now you might be thinking, can a cold plasma electrocute you? Well, sometimes, but because the number of electrons inside the plasma is very less, it will just feel like a tickle. Also note that the net charge of a cold plasma is zero because of equal number of electrons and positive ions. So, most of the times you might not feel anything. But for your information, for a person to die by electric shock, a huge amount of electrons should pass through the body, completing the circuit, which is highly unlikely in case of cold plasma. There are several applications of cold plasma. Like in dermatology, it is used for collagen formation and rejuvenation, killing of microbial pathogens in case of sterilization, wound healing, and for killing of cancer cells. Now you might be thinking, how does cold plasma kill cancer cells? It has neither enough electrons to electrocute nor heat. Note that the killing effect of cold plasma does not depend on both the above properties. ROS level is an important determiner of fate in mammalian cells. Higher levels of ROS leads to cell death, whereas physiologically small levels of ROS can induce immune response and wound healing. In cancer cells, naturally ROS levels are quite high. And cold plasma produces ROS. This is because the electrons produced from the inert gas reacts with the 20% nitrogen and oxygen present in the gas. And when this gas is applied on the cancer cells, this further pushes the ROS levels higher, leading to death. However, in case of normal cells, the ROS levels are far below the threshold level and therefore remain unaffected. These are few references, those might be helpful. Thank you all for watching this video. See you in the next video.